one of the things I wanted to mention is, number one, the reason I wanted to speak, or well, Christine asked me to speak too, but I think the work I've done, of course, has been in a forensic caseworking lab, and I thought it would be helpful for you to see, first of all, what we've done, and some of our research is a jump off from what Christine has done, because she helped me from the beginning. But then also, I kind of started to veer off on a different path, because at the time Christine was doing her work, I called her up. We had bought the microscope. I called her up and I said, you know what? I don't want to reinvent the wheel. I work in a forensic laboratory. I don't have time. I want to do a validation of this if I can and try to do it quickly. Well, you can see this is 2 years, 2.5 years later. It hasn't been quick anyway. But she couldn't divulge a whole lot of information to me because she was doing this for research. She was doing this for a research lab, and she wanted to be able to do a publication with her boss. And so, of course, with research, some of that can be a little secretive until a publication has been made. So she did guide me and helped me a lot, but then I kind of started to veer off on a different path. And so what ended up happening here, and hopefully you'll see this in my presentation, is that we've kind of done something different. But we have ended up in the same result where we're getting results. And so this is, it'll kind of give you a different perspective. And hopefully I'll hit on everything that I want to. And I hope that Christine and Pat, if you see something that I've missed on a slide or something you think of, just please interject. And of course you can ask me questions, but I'll try, because I have a lot, I'm going to try to get through most of them, and then maybe we can have some questions at the end. Okay, so for the research and experience that I had, I tried to lay out the highlights here. First of all, why choose LMD for our crime lab casework? There's a very short answer, and then I think the entire presentation sort of lays out the long answer. I mean, you'll see just throughout why I think that LMD, and why my boss also thinks LMD will be good for casework. I'm just going to hit on elimination of the manual extraction, which Christine kind of talked about, a little bit about reproducibility and sensitivity. How did I make this more sensitive to maybe then, number one, get detection of 50 sperm, but number two, can we go a little lower? I did end up during, there was a lot of trial and error at the beginning, because Christine, of course, had done some stuff. She was telling me, okay, try this, and then we did some stuff, and there was a lot of trial and error, which of course is research. And then once I started to sort of hone in on a particular procedure, I did have to do some troubleshooting. Then I'm going to talk about a single amplification and the optimization of that single amplification. What we tried to do in case there was the absence of sperm. And then at the very end, I'm just going to briefly touch on a streamlined novel process that we're going to try to implement, at least just for a basic differential of sorts, cutting the sperm, cutting the epi, and this is how quickly it's going to be done, and this is how it's going to work. I'm not going to steal Pat's thunder, though, because he's going to go into something like this, but even more extensively. Okay, and this is our microscope. This is the dinosaur we've been speaking about. This is the Leica AS LMD. This is what this microscope is called, and this is right. This is the first generation microscope. So now you're seeing the new one here. So that's exciting. You guys get to see the brand new, fast. I mean, it cuts so much faster than the one you guys have seen. So, but this is our microscope. Okay. So why choose laser microdissection? Okay, well, at the North Louisiana Crime Lab, about 45% of our cases, all of our DNA cases, about 45% of them involve some type of sexual offense. Okay, now granted, not all of those cases are going to give us a positive PSA or a positive sperm, but we all know, I think mostly across the board in most labs, it usually runs, let's say, 30 to 40% of those are positive. So if you start thinking about this right away, you realize, well, that translates into a lot of differentials, a lot of work. And like I said, when we first introduced ourselves, I had worked in New York City before where they did Kelex extraction. I'm not sure if they're still doing that, but a relatively quick, process. But then I moved to Shreveport, started working at the North Louisiana Crime Lab, and they were still doing the organics, which is, it is a very nice procedure because it's very clean, whereas Kelex isn't always very clean. But it takes, a day and a half. I mean, it takes forever. You do the overnight incubation, but before that, you got to do your screening. You got to do your phenylchloroform cleanup and then your centricons. I mean, it takes a long time. So I was like, oh my God, this is going to take forever. How am I going to get any cases done, And then I went to the meeting like I talked about in 2004, and I saw Christine's talk, and I immediately saw the application. I said, oh my gosh, if we could get something like this to work, it would be great. So we wanted to eliminate that bottleneck, that differential extraction procedure in the lab and how long it takes. That to us was a bottleneck in the laboratory. So we kind of talked about it in a DNA meeting that we had, and we said, hey, we need to at least do something different, whether it be a new differential procedure, Helix or whatever. And of course I jumped up. I was like, oh, this LMD looks so cool. And of course, little did I know, my boss was like, oh yeah, great. Okay, Kelly, you go, you can do that. Bought the microscope. And so anyway, I took on this whole project. Okay, so right off the bat, I wanted to tell you about some just generic disadvantages. Okay, number one, we've all talked about this, initial cost. Okay, yes, the laser microscope is very expensive. And again, though, some of the microscopes out there are a little cheaper, but you get what you pay for, okay? But initial cost is one thing to think about. But kind of like I mentioned in the lab, initial cost, it was the same kind of thing with the 377s or the instrumentation that they used for genotyping. They went out and bought this stuff because eventually they realized the need for these. So I think maybe in time, if this becomes an accepted method and people really feel like it's going to work, maybe your labs will just say, hey, we need this. Of course, my feat here, of course, that meant I had to do a novel validation. Novel validation takes a long time. So that was one drawback. The pen slides that we've been talking about do cost about $4.25 each, I think. Is that correct, Andy?
$233 for 50 slides.
So I think that I had figured that out. We talked about the pen foil contains these pores, but as most of you saw yesterday, that's really not that big of a deal. It's really, you get in time, you just kind of get used to looking at it. And maybe, again, maybe that'll be taken care of with the director slides. And I don't know if that's right. I put pen slides are like a product. I get a box that says Leica on it when I get these slides. But then now with the Palm, she was saying hers was...
All membrane slides, regardless of manufacturer of laser microdissection, come from one manufacturer. It's a company called Microtest, and they're from Germany. If you look, Becky, if you look at your box, if you buy the slides from Zeiss, it says Microtest on it.
Is that what these say too? See, I failed to see that.
All membrane technology slides come from one manufacturer. It's called Microtest in Germany.
Okay, so except for the pen slides, however, you see in red here, there's really no other consumables with the Leica. So yes, you're buying the instrument, it's expensive, and then two, you're buying the slides. But pretty much everything else we've done in the lab are things that we already have in the lab. So you're not having to buy new tubes, you're not having to buy a new extraction kit, you're not having to buy, really for the most part, everything is just these pen slides, that's it. So that's, to me, is actually kind of an advantage.
What's the cost on the director slides?
Oh, it's more.
The director slides in 50 quantities are now at $12.50 each. $12.50 in quantities of 50. And quantities of 10, I think they're $15 a piece.
Okay, so some of the obvious advantages of LMD. I'm just going to talk about the first two. Number one, right away you can see, hopefully we can eliminate that traditional extraction. At least we can eliminate the differential part. Because when you're cutting sperm, you're cutting sperm into one tube. Move over to the next tube, you're cutting epithelial cells, you're cutting those into one tube, and you've done your separation, period, done. Now, obviously, the next question is, can we completely eliminate extraction? An extraction and then a purification. Well, Christine obviously talked about this a little bit, Lyse and Go. Can use Chi-Amp to clean up, what do you have to do? Second advantage of LMD, well, I just said it, you get an absolute separation of sperm and epithelial DNA. Look at my notes here. Okay, and then sort of an underlying advantage, of course, is what we talked about earlier too, the quantification. Are we going to be able to eliminate quantification too? Because we now know exactly, or for the most part, almost exactly how many cells we're cutting and how many cells are going into the tube. Again, I think this is a much better way of assessing quantity than quantum ever was. And we did that for years. So something to think about. Okay, so the first thing that we came to was, okay, we have this little tube holder, and it holds PCR tubes. So the first thing was, are we going to cut these into here and then put them into a 1.5 mil tube? Or are we going to try to do some kind of extraction in this tube? So immediately, just the fact that we could cut into these small tubes kind of started the brain working. And I know this sounds crazy, but we said, well, what would happen if we just cut into these PCR tubes and then amplified? What would happen? Well, as you might guess, they did not adequately amplify. We got many partial profiles. At this point, we did sort of mess around with increasing cycles. We got artifacts. So basically, this was not any type of reliable way. But we said, hey, let's just try it, see what happens. So it didn't work. So then the next step was, okay, should we do a preamplification lysis? And some of this was help from Christine. She had kind of mentioned to me about lyse and go, and or doing a chi-amp cleanup of the cells and then amping. Two things: you don't want it to adversely affect your PCR, downstream. You don't want it to inhibit. And two, you have a limited amount of volume that you can work with by doing a preamplification lysis. Now here I put less than or equal to 10 microliters because in our laboratory the general procedure for any PCR is a 25 microliter reaction. How many of you in here do that? Okay, so a few. So our goal was, look, we don't want to go back to a 50 microliter reaction if we don't have to. Let's try to keep it, because you cut costs that way. You're not using so much of your kits. So let's try to keep it to 25 microliters or less. Of course, another goal was we wanted to be able to try low copy number sperm if we could, just like Christine talked about. With low copy number, you want to eliminate as many manipulations as you can. The fewer you do with the fewer number of cells, the better, because then hopefully you won't lose your cells. So we tried, okay, let me go back for a second. I did try lyse and go. However, as a disclaimer, this was, again, sort of the early stages of what Christine was doing. And because I wanted to try to keep it to a 25 microliter reaction, number one, kind of how we were starting this process was, okay, we were cutting into the lids of our tubes using just, PCR grade water. So I was actually cutting into water. And then for volume control, I was actually drying the water off in a vacufuge. So now all I have in there should be just cells without the water. And then what I was trying to do was I was taking the lyse and go, looking at their protocol, pretty much divided it in half. Instead of for a 50 microliter reaction, I was trying to do 25, and then tried to do it that way. It didn't work. I also did that same type of procedure doing a 50 microliter reaction. I still didn't have success. So, and on top of that, I wasn't using DTT. So, she and I kind of started to diverge at this point. She kind of guided me and said, well, try this, whatever. And then I kind of just, Pat and I kind of started talking and brainstorming, and we started to diverge. And I have never tried to do it the way that she's doing it now.
When I was working with the lyse and go, I'd also tried different concentrations of DTT with or without. And when I didn't add DTT, I was getting nothing.
Yeah, and that doesn't surprise me. Okay, so the next thing was we said, well, hey, why don't we just try ProK? I mean, that's what we do now when we're doing our digests of our samples, where we're adding ProK. So that was our next step. And pretty much what I did was, like I explained to you, cut into water, dry off the water, added ProK to the tube, and then did a lysis. And instead of doing, because lyse and go has a very specific cycling thing that it does in the thermal cycler. Heats up, cools down, heats up, cools down, it does all this stuff. I merely was putting it at 56 degrees in the thermal cycler, because you can program the thermal cycler to do whatever. And just like in your ovens, if you're heating or whatever, your digest, that's pretty much what I was doing. I put it at 56 degrees. for like 3 hours or something, 2 hours. Okay, and this is just a real quick summary of what I just said. We tried direct amplification, 50 microliters, Lysenko 25 microliters, and those were the ways that I described. ProK, and then we finally did try adding DTT with our ProK. And you can see right off the bat, this is a 25 microliter reaction. This is cutting 150 sperm, Profiler Plus, and we had at some point decided to start increasing our cycles. And I'm not going into that because it was this whole trial and error thing, but 30 PCR cycles. And you can see down below, yes, we're using a 377 instrument, and we still are. We do have a 3130 in the lab, but boy, we love that 377. We're working it to death. So this was doing 377, but the percent alleles detected, you can just see by the chart that with ProK and ProK DTT, we were doing much, getting much better recovery, much better DNA types. Also, what we ended up doing was we ended up going with the ProK DTT and not reflected in the chart was because we were getting better peak heights, higher RFUs with the ProK DTT. So we kind of settled on this sort of procedure at the beginning, cut directly into water. Like I said, it was PCR grade water, which we already had in the lab. This was something we already had. Using ProK. Now you see here I have recombinant ProK. That is one thing that we did choose to buy, and I may still go back and do some of this now because I've optimized this to just with our regular ProK and see what happens. We chose the recombinant ProK because we weren't doing a cleanup of our sample. Recombinant ProK is supposed to be just a pure type of ProK, and we thought maybe this would help just with the lysis procedure. And as far as the lysis, incubation in the thermal cycler, and then the PCR reaction, we did kind of go from this current protocols in molecular biology. I want to say it was April 2004, but I have a link to the ProMega website because I had given a presentation and I have a manuscript on there, and I do have references in my manuscript, and I have that link here in my talk. So you may want to look up that paper, but that's kind of where we started adopting our lysis times, which is 3 hours in the thermal cycler at 56 degrees. And then all we do is ramp up to, I think it's 94 degrees for 10 minutes to hopefully kill any, denature any proteins. The ProK, hopefully any nucleases, because that's the other thing about this. If you're not cleaning up, you have the potential for any nucleases, especially with like the epicells, to start to break apart your DNA. So anyway, ProK to the tube, ProK DTT, lysis in the thermal cycler for about 3.5 hours. That's what we do. Add your PCR reaction components to the same tube, amplify and analyze. Okay, and I did kind of brush over this briefly, but we did do some additional experiments in hopes to increase our sensitivity. Because yes, we were getting DNA profiles with Profiler Plus, but they weren't complete. And that's what we were shooting for. Especially with 150 sperm, that's more than half a nanogram, right? Am I calculating that right? Yeah, of DNA approximately. So it should have worked. It should work. We know that this, half a nanogram of DNA should work with PCR. Another thing, we thought, well, okay, what's another way we could increase? Increase in PCR cycles, of course, though Christine has shown 34 cycles works. Sometimes if you increase your cycles, if you're not careful or if the reaction isn't optimized, you can start to get artifacts. So we said, well, if that doesn't work, what if we decrease the amplification reaction volume? Okay, in our laboratory, we already have in place protocols before we were even doing LMD for reduced volume PCR. And there's a paper also on reduced volume that was put out by the North Louisiana Crime Lab. That's also in the manuscript on ProMega. So that reference is there. We have in place RV-PCR protocols for 15 microliters total volume for PCR, 10 microliters total volume, and 5 microliters. I didn't go down to 5 because 15 and 10 actually worked very well. And then, of course, we wanted to see, well, how, kind of like Christine, how few do we actually have to cut? With any type of increase in sensitivity, how many cells can we go down to? What's our optimal cut number to be able to get a profile? Okay, so I have quite a few pictures in here. And the reason I did that, of course, is just as from the viewpoint of a caseworker, I wanted you to see final results. I don't have a whole lot of number crunching in my my talk because it's just I was kind of going a different way. I wanted to get this validated, and I'm probably going to have to do some number crunching soon because I'd like to write a paper. Okay, so you can see here with this procedure we came up with, 150 sperm at 30 cycles using the ProK DTT preamplification lysis. I have here for depiction purposes the green only, 25 microliters, 15 microliters, and 10 microliter final PCR reaction volumes. And you can see just by looking here that as you decrease the volume of the reaction, you're easily getting an increase in your peak heights. The 25 microliter reaction actually looked pretty good doing this, but we said, hey, well, let's just see what happens if we go down in our PCR volume. Full profiles were obtained from all loci tested for these reactions. This was Profiler Plus. 150 sperm. Was this reproducible? I just did a quick, short thing, and this was with the lower reaction volumes, 15 microliters and 10 microliters. Profiler Plus, 150 sperm, 30 cycles. And you could see the ProK DTT preamplification lysis with PCR works. I circled this last one. The last one I had a flat line. And before I actually optimized this, I would see this from time to time. But I'm going to get into this in the troubleshooting, I think. I hope I answer a little bit of question. And actually, now that I've optimized it, I've hardly seen this. So hopefully that won't happen. But again, there's another QC. There's even QC that comes into that. Do you cut just one tube? We kind of talked about this. One tube. Do you cut two tubes? Do you triplicate? Those are things that have to be worked out. Okay, so now I said, well, what happens if I cut fewer sperm with the same procedure? Well, this is 100. And you can see I have 2 peaks drop out. Let me see. And I think for that 25 microliter reaction, those were the only 2 peaks that dropped out. Low RFUs, you can see about 157 RFU average. But yet with the 10 microliter, we had very high RFU, full profile, and you can see here a little bit of stutter. I did label the stutter, but it looked really good. Okay, here's 50 sperm. And you can see again we had some dropout. 25 microliter reaction was okay. Again, our RFUs are pretty low, but the increase in sensitivity seems to be gained by doing that low volume PCR. And that was, again, with that 10 microliter reaction, that was the only peak that dropped out. You do start to see some stochastic effects because look, I can't remember what, a D18 locus. The longer peak was called, but the shorter one dropped out. You kind of start to expect that with low copy number and with the reduced volume PCR. Okay, so I think then we've gotten to a point where we said, okay, with LMD and this preamplification lysis technique, we feel we can eliminate that traditional extraction procedure and really eliminate the quantification procedure because we're counting and we're assessing the quantity. And we can get separation of sperm and epithelial DNA. So this is just to reiterate. This is a 50 sperm sample, 30 cycles, 10 microliter, reduced volume PCR. So I was excited. I was really excited. I was like, great, this is working. I'm excited, And we did do epithelial nuclei. You can see here at 50 epithelial nuclei, 30 cycles, 10 microliters, got a nice profile. I am seeing some dropout. And this is 25. But as you can see, we can get separation of these 2 components. This definitely will work. So just in summary, this is my early research. Replace the DNA extraction and purification with the novel preamplification lysis technique. We can get physical and complete separation of sperm and epithelial DNA by doing this. the reduced volume PCR at 30 cycles is reproducible, and our sensitivity at that time was, 50 to 150 sperm, because that's kind of, what I was working with. And this is the link that I was talking about, ProMega, because I kind of gave this talk at ProMega in 2005, and so I had to type up a manuscript after I did the oral presentation. I didn't know I'd have to do that. I had to type this whole thing. I was like, oh, geez. But anyway, so that goes into a little more detail about what I just talked about, and there are references on there that you could go to if you wanted to. Okay, so now it's kind of like, okay, we're going to go from research now, and I'm going to try to start getting to a point where I'm really sort of validating this, because, as we've all spoken about with the DAB guidelines, there are ways to do a novel validation, and there's a way to do an internal validation, and there are certain things you need to do. And being that this is a novel validation, I still have to explore a little bit what I need to make sure I've done. But anyway, that's a whole nother ball of wax. But the first thing I did was I had to do a little troubleshooting, because I think it was right before or right after I spoke at the ProMega meeting, I started to get some really troublesome things happening. First thing I want to talk about is static, okay? We've kind of talked about static with the microscope and with the pen slides, and from what I gather with Andy. Now, I have not used any of these other systems, so I don't know how those work. But I've seen with the pen slide, if it's dry, and Christine talked about this, if it's too dry, you're cutting, when you cut it, it can just move over and stick, rather by dropping, and by gravity, static pulls it on the slide. And sometimes what happens is if it's really staticky, you'll cut that, it looks like it disappears. And then all of a sudden you're scanning the slide for something else, and you see this piece stuck way in a different part of the slide. So it's not readily even apparent sometimes when the static has happened. Usually you do know, because there are a couple that you see stick close by. So humidity was an issue, but that is pretty readily fixed. Like I said, we moved our microscope. Our microscope used to be in a big room. We moved it down to a smaller room in our basement. And it's nice and humid in there actually most of the time. Of course, we have the luxury of being in Louisiana, so it's humid. But that, just buy a humidifier, that's easily fixed. You buy a humidifier, you get a hygrometer, which is the thing that measures the humidity, and you should be good to go. But like Christine was saying, sometimes even too much moisture can kind of cause them to stick too. But I found that for the most part, static is when I have the problem. Another thing that was brought to my attention when the engineer came to do, just to kind of clean the instrument, what do they call the annual?
Preventative maintenance.
Yeah, preventative maintenance. And I was talking to him, I'm seeing the static, I don't know if it's certainly it's going to affect if you're not recovering your sample, it's going to affect your results. So I was picking his brain, should we get a static gun? We talked about getting a static gun. We talked about, all kinds of stuff. And he's like, well, we told him how much we were cutting into. And like we said, we actually cut into these domed caps. And they're fairly, a pretty good amount can fit in there. And he said, well, the fewer, the less volume of liquid you have in there, the more plastic that's exposed. And plastic has a tendency to cause static charge. So he said, maybe it would help if you cut into more. And I said, well, yeah, I guess that'd be okay. But my thinking was, well, if we're drying off this liquid, is it going to take longer to dry off double the amount? So, here I am trying to cut down on the time, make this faster, and I didn't want, I'm like, oh, I don't know. So anyway, but I went ahead and said, well, let me try this 50 microliter thing. And believe it or not, it did make a huge difference. I don't seem to have near the problem that I did before with static. If I do, it's generally because the room is drier. But otherwise, and like I said, that's fixed pretty easily. So I found cutting into the larger volume helps a lot. Plus, if
still H2O is what you're cutting into?
Well, I'm going to keep going, but for now I was, yes,
Okay.
at this point. Next, I had what I'm calling an electropherogram conundrum. Because at first, I had no idea what this was. It was driving me crazy. And you have to understand, I'm not making excuses, Pat, but it'd been a while since I'd had all the very technical things that you learn in your molecular biology, and learning about the whole PCR reaction, how the magnesium and the buffer and everything's coming into play, and And I had never really truly done a research project. So this to me, I mean, to do this for me was a big thing. So I'm like, what is going on? I'm getting what I called these dye-saturated E-grams. All of a sudden, I mean, it happened, like things were going great. And I'm sure any of you who've done research, of course that happens. Things are going great, and then all of a sudden, you're stopped dead in your tracks. Well, that happened to me. I'm like, what is this? Is it contamination? Nonspecific binding? What's going on? Well, at the time, my first sort of instinct was, at the time we had another girl working on the microscope who was working with fluorescence. So I said, okay. And honestly, we weren't being that careful about cleaning the stage and cleaning the tube holder. I mean, we were just doing, research. And, from what I could tell, nothing was going on with the samples getting contamination or whatever. And so I said, well, is it because, is there fluorophores sticking to the slide and they're falling off into my tubes? And then, of course, with an instrument that detects fluorescence, is this causing a problem? I was trying to think, what is this? Anyway, so I got to talking to her, and I'm like, God, this is driving me crazy. What is this? And she's like, what is it that's happening, with your samples? I'm like, I'm just getting this mess. I showed her the electropherograms, and, well, here, I'll show you. This is what it looked like, something like this. Have any of you ever seen anything like this? Well, anyway, so I went from this to this. I was like, what's happening? So anyway, she said, well, that's really weird. I'm not seeing that. And I'm like, what do you mean? She's like, that's not happening to me. I'm like, well, what are you doing? And we talked about, she was doing the same, because I had sort of developed this procedure, and that's what she was using for her fluorescent, analysis. I'm like, well, I don't understand, what's going on? Well, she said, well, I'm using, she was doing little different slides, because there's the pen slides, there's also PET slides, PET slides, there's POL slides, and because she was working with fluorescence, and Andy talked about the autofluorescence of the slides, I think one or two of those slides work a little better as far as no background fluorescence. So she was doing some other things. I'm like, well, gosh, I can't imagine it would be the slide, is it the tubes? She wasn't even cross-linking her tubes before. I was cross-linking my tubes. I'm like, what? I mean, I tried. I changed one at a time. I tried to change everything, the ProK, everything. And she said, well, I'm doing identifiler. And I'm like, well, why would that matter? My kit hadn't expired. I checked everything, expiration dates, And I said, well, you know what? I don't want to really approach identifiler just yet, So I tried profiler. We had some profiler kits. So it's the Profiler Plus, I did profiler. I still saw it. So I was like, oh, it's not the kit. It's not the kit. Well, anyway, at some point I finally said, well, okay, I'll just do identifiler. Well, what do you know? I did identifiler and it worked. I have, so I'm like, what? Now, I still don't know why this happened, right? So I did identifiler, and this is what I got. It looks beautiful again. Well, I said, okay. It bothered me that I didn't know why I was getting that really ugly thing before, and now I was getting this. But I said, well, okay, I'm just going to go with it. So I moved on, Well, what do you know? Of course, before I went to the academy meeting this past year, I spoke at the academy meeting, and again, right before I went to present, I started seeing the same thing with identifiler. I was like, okay, so there's something going on here. But anyway, so then I decided, well, with identifiler, I'm going to have to optimize what's happening. So I'll get back to this conundrum here in a minute. Okay, first thing I did was, instead of cutting into the PCR grade water, let me think about cutting into TE4 buffer, because one of my other coworkers has done studies using the reduced volume PCR reaction and identifiler, storing DNA in water versus storing it in TE4, and of course it does better in the TE4. The identifiler reaction at the reduced volume PCR seems to do better with the TE4. So I said, okay, maybe I should try to start cutting into the TE4 instead. And believe it or not, she's done a similar study with Y-filer, and it seems to be the opposite with Y-filer. Why, I don't know. So it seems to do better in water with Y-filer than with TE4. So I don't know why. But she had done this study, and I said, well, maybe I need to start doing this. Also, we messed around with the PCR cycling. I'm going to touch on that TE4 again in a second. I did sort of something similar to Christine, but again, some variations, because of course then Pat and I started brainstorming. What if we do 28 cycles, stop it, and add, tack and do 6 more cycles? What if we do 20 cycles, stop and add, tack, or add more reduced volume master mix and do 14 cycles? What if we stop at 20 and do 10? We kind of did some of this messing around, but really none of them worked for me as far as increasing sensitivity or getting a better profile. So I just bumped it up one more. I had already done the 30 cycle thing. I said, well, what happens if I do 31? And bumped it up to 31, and of course it looked great. It worked. It was fine. No really, no weird foreign peaks coming in or anything like that. And then of course we had to mess around with magnesium. Again, this is something where I had forgotten from my school days, and I remember it being stressed to me at the time. But one of the things I remember about PCR is they've always said magnesium is crucial. It's crucial. It's crucial. And when you start to mess with, if we had only been doing 28 cycles, identifier, maybe we wouldn't have to think about it so much and doing a regular 25 microliter reaction, whatever. But see, here we've dropped down to a 10 microliter reaction. We've increased our cycles. So things are going to start to change in that reaction during, PCR. So, and then also with the TE4, because I'm cutting into TE4, cutting into 50 microliters, drying off the 50 microliters. So now we're concentrating, the salts, the EDTA in there. It's going to throw off that reaction, or it could throw off the reaction, the pH. So I then had to go back. Oh, okay, great. Now I got to figure out how much magnesium do I need, So I did. I messed around with varying, extra magnesium in there. And sure enough, it basically fell into the range that it should with the previous reduced volume PCR paper. I need to make sure there's at least a 0.5 millimolar to 1.5 millimolar extra magnesium in there. Okay? Okay, so going back to the TE4, another thing that I did, and this was very recent, Pat was kind of talking to me, he's like, well, because you're drying out that 50 microliters, you need to think about the pH and on, chemistry, this and that, millimolars, and I was like, okay, whatever. He said, well, Kelly, try changing the TE4 concentration, see if that helps, or hurts or whatever. I said, okay, I'll do it, So I did it with the normal amount, and then I did it with half the amount, a quarter the amount, and a fifth the amount that TE4 calls for. And I'll show you, but we ended up saying, okay, the normal amount is fine. Again, with the added magnesium, 31 cycles, everything looks pretty good now, okay? So here we go. This is an identifier electropherogram. This is with 50 sperm. Every single peak was called, 29 and 29, 100%. This is great. Okay, so remember our electropherogram conundrum? This was my old slide that I showed you. This is what was happening with Profile Plus. I was pulling my hair out. Did we solve it? This is what I started to see once my TE had more dilute amounts of the tris. Okay, so you're saying to yourself, well, how did this happen? Well, okay, me being, just, okay, I'm trying to do all this stuff, whatever. I would hold the same TE4 bottle for a long time. I made it, we make it in our lab. We make TE4. Some places buy it. We make it. And our boss has always said, oh, really, after a week or two, you need to throw it out. Yeah. Well, looks like what's happening is over time, if that's just sitting there and I kept using the same, I make a 5 mil tube, I just had it downstairs by the LMD and I would make it, and sometimes I'd be like, oh, I should probably make new TE4, but I'm not gonna, Well, this may be what, these look a lot like what I was seeing with the TE4. It was the TE4. So, and I truly think that's probably what's happening, because this is the 1/5 X. 1/5 the amount of tris in the TE4. So, lesson to me, and probably to everybody else, if you were to do something like this, don't let your TE4 sit around. Pat's like, Kelly, after a week, just throw it away. I said, okay. You've convinced me, because I pulled my hair out for like 3 months last summer trying to figure out. And the funny thing is, I know I think I had made new TE4 because I was trying to pick one thing at a time. But I don't know, I don't know what happened. I just didn't figure that out. So hopefully we figured that out. Okay. So after optimizing that identifier reaction, well, how many sperm do we truly need? So here we go again to sensitivity, and we're going to try even lower numbers of sperm. Okay, so we've pretty much settled on 50 sperm. Now lately, after I've optimized the identifier reaction with the magnesium and the TE4 and everything, I don't think I've seen one flat line. And that's probably out of 16 to 20 samples. I think the whole flat line issue may be static. You know, if you're really having a static problem and you're not getting enough of your cells into your tube, I think that's the biggest thing. Number two, it can be a user thing. You know, going back to that tube holder. You know, with our tube holder, again, there's no back plate. So I'm trying to hold it with one thumb, hold the little tab of the PCR lid, and, you know, kind of sliding off the tube. Well, there have been once or twice where my thumb has touched that liquid. Well, there goes all your cells on your thumb, you know, or at least maybe a good number of them. So I think a lot of that is just little nuances, you know, a little error, you know, human error or maybe the static. But I think for the most part that should be solved with the humidity control. Okay, this is 25 sperm identifier. This is before I finished optimization of the magnesium. So this is a slightly different magnesium concentration. You could see 25 sperm, I got 23 out of 29 peaks. After I optimized, I'm only missing 2 peaks on identifier. I mean, that's great, 25 sperm. Okay. 15 sperm identifier, this was before I finished optimizing the magnesium. This is after I optimized the magnesium. So boy, you can see a clear difference, just the magnesium. I mean, makes a big difference. Again, this is at 31 cycles, identifier, you know, optimizing your magnesium, cutting into your good TE4. But then the question becomes, though, really, this could be something for discussion or whatever. Really, do you have to go this low? Well, probably for the most part, you won't have to. I mean, I think 50 is a good target. Again, you know, like you guys saw yesterday, even just the 3 spots of 3 microliters you had on your slide, if you have a good sample, there's going to be plenty of sperm there, you know. But that's something you're going to have to assess in your laboratory. You know, first of all, the first thing that's going to have to be done when you make a slide for LMD and you're going to look for sperm, you have to be able to assess somehow, well, how do we know that there's enough sperm here to move on? You know, that's going to be the first thing. You're going to have to say, well, do we have to make sure we can at least count 100 sperm, or, you know, do a quick somehow scan and sort of estimate how many sperm are on that slide? But for the most part, gosh, I can't even imagine that you'll have to go this low. There will be occasions. I'm not saying there wouldn't be, but you know, Pat and I, of course, have talked at length, and, you know, that may come to a thing where you cut at least 2 tubes of your 15 or 20 or 30, 40, 50 sperm, you know, or 3 tubes, you know, so that you always have, either do them in triplicates, run them all together, and then take the best of 2, you know, or where you set 2 of them aside, do the 1, you know, depending on your policy. You know, if you're going to do identifier, do you have to do a second amp, you know, a duplicate amp or whatever. So that then becomes an issue of QC and your policies in your lab, and, you know, those are all things that kind of have to be worked out. Okay, but now what do we do if there's no sperm observed? Okay, now we've got, okay, Christine's approach is a little different than mine, and I didn't talk about this, it is in my ProMega paper. The way we spot, or I've been spotting the slides, is I actually do a pellet, you know, PBS, make your pellet. I stir it up, you know, in about 75 microliters to 100 microliters after taking off the supernatant. And I'm taking a 25 microliter and putting it on there, 25 microliters. And sometimes I'll do, and now a lot of times I do 25 and 25. I'll put 2 big spots on there. Because if you think about it again, your sample is no longer in your tube, per se. Your sample is now the slide. This is how you're storing your sample. It's on this slide because it's not inert anymore. It's on this pen film. Of course, we do director slides. That might be a whole nother story. But, or like I talked about, you could keep half take off all but about 100 microliters of your supernatant and keep half, mix it up, keep 50 in a tube, your 1.5 ml tubes, freeze it. So you have that. Take the other 50 and spot 25 and 25 or 20 and 20, and that way you've got these on your slide and you've got some in your tube. So there's, there are ways around that too. But what do you do if there's no sperm observed? You've got the slide now and your sample's on here. Well, what if there's no sperm? Well, you guys, this is no longer an inert slide. It's a foil. It's something you can cut out. Well, why not just cut that whole spot off your slide and extract it then? Because then you could see, well, is there a mixture of, let's say, just skin cells? And of course, Pat's going to go into that even more. Or can you do at least Y typing? To see if you're going to pick up any male type from that sample. So we said, well, shoot, let's cut that spot off there and see if we can just do a regular extraction of the spot. And so that's what we did. We did a side-by-side comparison where we, kind of like I spoke about, we left about 100 microliters in our tube, mixed up the pellet, took half, put it on the slide. So I think we did 50 microliter total. Took 25, put it on the slide, and left 25 in the tube. And did side-by-side extraction, organic, and then extraction of the cutout pen spot. No significant difference. We got STR results, but from both. YSTR results from both. So there's really no problem with that. That film doesn't seem to inhibit PCR or anything like that. Of course, this was doing an organic extraction. We do have a QIAGEN EZ1 robot in our lab. We haven't done the extraction using EZ1, but that's probably something we'll do. And I have a feeling it will be fine. I don't think it'll be any problem. So here we go. From that foil cutout, this is a mixture of 1 to 20 male to female epithelial cells. And you can see, we see a female profile. You don't even see the Y, by the way. This is from the foil cutout. But yet we still get a male profile. So with YSTR results, we're using that foil cutout to extract. We still can pick up the male. There seems to be no problem. Okay, so going back to advantages. Kind of like what Christine talked about. First, yes, we can eliminate traditional extraction. Yes, we should, be able to get separation of sperm and epithelial DNA. Also, because you're doing LMD, is the effect of traditional PCR challenges minimized? 2, can you decrease your analysis time for a sexual assault sample? Well, we hope so. That was one of the other things. Can we do that? Well, these are some things that may be readily obvious, but may not be. Number 1, if you're simplifying your mixtures, your interpretation is going to be so much simpler. I mean, think about how often we have these differentials, and we're going to do a likelihood ratio. Are we going to do a probability of exclusion? Are we going to deduce our major profile and do statistics on that? And right now, there are so many different ways that labs do, well, not that many, but there are different ways that labs do this. How do we deal with statistics and mixtures? So because the majority of our cases, or a lot of our cases, are sexual assault in nature, and therefore, by nature, we may have a lot of mixtures, hopefully this would be, for the most part, gone away. Unless you had, like Christine, a sample that just, you can't separate the sperm from the epithelial DNA. Of course, another thing that would come into play if you have 2 sperm donors. We haven't talked about that much, in this class. But yeah, if you have 2 sperm donors, there's no way you can separate them this way. So therefore, your difficult statistical interpretations are eliminated. For your writing your reports, and then to explain in court. I mean, I don't know how many of you have testified or have to explain likelihood ratio in court, or probably exclusion to a jury. I mean, all that would be gone. So these are some other advantages of doing LMD. Something that Christine hit on. When you're not collecting the whole sample on a cutting or on a swab, are you then not collecting contaminants? You're just cutting very specific little cells. So are you cutting down on your contaminants? Are you cutting down on inhibitors because you're not collecting all this dye or anything that might be on a swab? And And of course, because of doing these elimination of contaminants, elimination of inhibitors, then could you increase PCR cycles? Of course, we've already talked about that, but that was one of the theories behind that. If you're not collecting a contaminant or an inhibitor, can you bump up your PCR cycles? Because right now in the forensic community, everyone's pretty much, ooh, don't go above 28, unless you can help it. Though I think there are some low copy number procedures now that they're increasing. I think Teresa does, right?
Yeah.
What does she do? How many?
31 cycles.
Yeah, 31. Oh yeah, maybe is that why I bumped it? Because I think I read her paper.
Yeah, I think you talked to her.
Yeah.
Yeah.
So, okay. So through all this, in addition to using the LMD, by eliminating the traditional extraction, and by separating physically the sperm and epithelial DNA, we then envision a new way of processing and storing our sexual assault samples. So a whole new process is going to come about in our lab if we implement this. And I don't want to go too crazy because Pat, I don't want to steal his thunder because he's going to go into this. But 1, you're going to prepare your slide. 2, you're going to examine it using the microscope. If you have a positive sperm identification, you're going to proceed with LMD, your preamplification lysis, reduced volume PCR. If you have a negative sperm identification, we're going to probably cut out the spot and proceed with just a traditional extraction and then amplify it doing regular STR and YSTR testing. Just see if we pick up any male. And this is similar to some of Pat's slides, but I changed it up just a little bit. So this is how it's going to look. You have a cellular extraction in your tube, okay? You're going to perform your supernatant testing, AP, P30. We do the Avocard, but I know some labs still do the P30 assay. At least they were doing that in New York City before, I know. Are they still doing that?
What is it?
The P30 ELISA?
Yeah.
Yeah. But anyway, you'll do whatever you need to do on your supernatant. Spot the pellet. Like I said, we do a 25 microliter spot, and I'm generally now doing 2 spots. So you've eliminated your epithelial digestion. Okay, then you're going to use LMD to do your cell dissection into your tube. So here you can see in my depiction I have maybe you have a 4-tube holder. You could maybe do 2 of sperm and 2 of epithelial cells. And like I said, with our microscope, to cut 50 sperm on a decently populated slide, this was not heavily populated. This is, good amount of sperm, about 15 minutes or so. But gosh, with these new microscopes, it'll take no time. And same for the epithelial. It's not going to take very long. Do your preamplification digestion in the same tube. This is all happening in one tube. You're going to cut out purification, cut out your quantification, and amplify in the same tube. So I'm sure you guys can see right away this is really shortening the time. Really shortening the time. To get an idea of presumptive testing, I feel, and I think I gave generous times on all these, about 2 hours. That's if you do a 1-hour shake of your substrate, whether it be a swab, whether it be a cutting. I generally let mine shake for about an hour in the PBS. But then you're going to do your AP, your PSA testing, and your slide preparation and staining. And I gave about 2 hours for all that. You're going to examine for sperm and cut nuclear material. And honestly, 1 hour, I can't imagine it taking you 1 hour. But that would be, I could see that happening if you had a hard time seeing if there were sperm there, or if there were sperm, let's say there were very few, or if you had a pellet that was really thick in epithelial cells and you said, oh, geez, maybe I need to go back and dilute the pellet, or maybe do a mini lysis procedure to help clear out some of that epithelial DNA. So it depends on the slide, probably.
How much of the swabbing are you taking for this?
Actually, it just usually a third.
Clip?
Yeah. But you could do a whole swab. We do a whole swab right now with our regular testing. We take a whole swab because most kits anyway, you have 2 to 4 swabs. At our lab, we do a whole swab.
So you still have some remaining?
Yeah, absolutely. You always have to take that into consideration. You don't want to consume the entire sample. But I've done this on like a third of a swab. Drying of the TE4. Like I said, I cut into a TE4 buffer and then I dry it off for volume control later. So that takes about 45 minutes. And actually, I think I've stopped it at 30 minutes before and there was still some liquid in there. I think 45 is probably the shortest I can go. I used to do it for an hour and a half, but I found I didn't need to do it that long. Only about 45 minutes. Preamplification and thermocycler, the preamplification lysis, I do a 3-hour soak at 56 degrees, just like, you know, in your incubator or whatever. Ramp it up to 94 degrees for about 10 minutes to denature the proteins and then stop. But generally what I do is I do this first stuff in one day, and then I do the overnight, you know, overnight I put it in the thermocycler for the lysis. And it goes down to 4 degrees at the end, so it just is refrigerated. And then the next day, I do the 31 cycle PCR and, you know, run the gel. Of course, you know, most people are doing 3100s. So, you know, it's much quicker. This is so much quicker. I mean, okay, so LMD coupled with the preamplification lysis definitely improves and streamlines the analysis of sexual assault evidence. Something else I wanted to point out, if you didn't pick that up, this procedure that I have come up with also frees up analysts' time. I mean, if you go back to this slide, most of this stuff, you can be doing your paperwork, writing up reports or whatever while this is happening, because, I mean, there is so little time I'm actually at the bench adding a reagent or whatever. I mean, it's so minimal because, you know, you're doing the PBS soak, you know, sitting for an hour, you can go do something. You do probably the most time-consuming part is the actual presumptive testing. Cut your sperm and cut your epicells, you know, and that will vary in time. Dry off your TE4. You can go sit at your desk again or have coffee, like Andy says. Then you just add, you know, your ProK DTT real quick to your tubes, overnight soak. Next day, you add your PCR reagents, thermal cycler, 3.5 hours. Make your gel. Yes, it's more time consuming. And then put it on the gel, go. I mean, most of this stuff is really downtime. So that's what I like about this too, is not only is it speeding up the time it takes to do these samples, but you're also freeing up your time a lot too. So you have time to sit down at your desk and do paperwork. I mean, we all know how much paperwork we have. Okay, so, and you do have some extra slides in your presentation. Those were actually meant for, those are more for the technical leader managers. There were some things, because, you know, we're going to talk in that class a little more about validating, what's the best way to validate and stuff. But if you guys see something on there you want to talk about, we can always talk about that maybe later. I do want to look into, you know, I was trying to really focus in on getting a procedure down before I started to mess with it a little more. Because I would, of course, want to speed this up even more. I mean, Christine's is so much faster even than mine. But I'd like to think about maybe seeing if I can shorten that lysis time from, you know, 3 hours at 56. Maybe I can just do an hour, you know. So I might mess around with that a little bit. I do want to do a more full-blown mixture study, and that is primarily for the validation. Because, again, for validation, there are certain things you have to make sure you do to show for the DAB guidelines that you've done these things. And I've never done a really full-blown study of, like, you know, like what Christine did, ratios of epithelial cells to sperm cells. You know, can I still get successful separation and whatnot? So that I definitely want to do. I'm going to start doing, you know, we're really to a point where I think we can start working on some non-probatives. And then, of course, really one of the last and final stages is going to be, okay, what are all the things we have to consider to put this into place for casework, all the QC issues. You know, we've kind of been, you know, thinking of those things as we go, but, you know, how are you going to do your positive control? You know, how are you going to do your blank controls? You know, what will we do if we get a flatline sample? You know, how are we going to make a worksheet, you know, to do this? You know, there's going to be all kinds of things that we'll have to, you know, think about to actually put it into casework. So, okay, now, for this class, you know, Christine said, Kelly, are you doing any cases yet? I'm like, oh, no, you know, we're still trying to get, you know, and I was in the process of optimizing at the time that she and I kind of started talking about this. I said, but, you know, we're pretty close to getting a good procedure down. You know, I can try to do some cases before the class. Well, I literally did them right before, the week before. But the great thing is I did 4 cases in 2 days. Okay, I mean, it was so simple. And this was not cutting them on the same same time, tube holder, you know, different tubes for different cases at different time. Okay, now, I start with case number 2 because case number 1 I want to talk about last. Okay, and I'm going to be honest here. Case number 2, 3, and 4. because I had to quickly come up with some casework samples. And you need to find non-probative or adjudicated cases, and I just didn't have the time to get on the phone to say, hey, can I use this case, this sample for testing and research or whatever. I just didn't have the time. So, but what I did have handy were some proficiency tests. Okay, so I took 3 proficiency test swabs, those sexual assault or crime scene kit swabs or something, whatever they call them, from old tests that I had kept. And I tested them just to see, can I get the same results? Is this going to work? So that's what these are. So, this is a little more ideal type of sample, but I wanted to kind of do some just things that I had not done before or that I hadn't prepared. Okay, so this is case number 2, and I didn't go into depth either about, what Christine did. I literally had to throw these slides together at the last minute. That's why they're not in your binder either. But this is case number 2. Okay, this is my electropherogram. This is, again, 50 sperm with identifier, the optimized version, 31 cycles. And this is what the electropherogram looks like. And you can see here, well, it might be sort of hard for you to see, but okay. What did I hear you say?
A mixture.
Is it a mixture? Okay, every single peak I've circled is in the stutter position. Let me just tap this again. Wait, how do I? Oh, wait. Take those off for a minute. Okay. Now I did these blind. I didn't have my previous results there or anything. I just, did my testing, pulled up the electropherogram, and then looked at it and said, okay, what do I have here? Do I have a mixture? What do I have going on? So in the back of my head, I'm saying to myself, if this is an LMD dissected sample, like we talked about in the advantages, if you have shown that you can get a clean type, it's going to be easier to identify artifacts versus like a mixture. Okay, what is the definition of a mixture? Could someone give me a definition? Or so, like what is one thing that you have to see in a mixture? If someone just off the top of their head. At how many loci? Yeah, usually that's sort of a start. Secondly, what else?
Peak height imbalance.
Right, peak height imbalance, very good. Okay, well we do have both of those here. So it's a little tricky, but again, these are laser dissected cells. So can you throw out some of that stuff? Can you throw out some of that old stuff? Anyway, also the thing about these 3, as you can see, they're at the shortest loci, and they're all in stutter position. I mean, right away I said, you know what, these are all stutter. I mean, just in my head, just right away I said, these are all stutter. And again, I did not know what the final type was supposed to be. I didn't have my, previous results in front of me or anything. I had no idea. So just by looking at this, I said, I think these are stutter. And part of this is from doing LMD and doing this 31 cycle stuff. I do have a feel for sort of, the imbalance you might see, and the stutter heights are a little higher, but those are again documented with reduced volume PCR and also low copy number analysis. I think increased cycles, you have a tendency to get this early event stutter is what it's called. So if early on you get a stutter that starts to come into play, generally then when it amplifies it's a little higher. The higher your cycles. But anyway, so that's an interpretation thing again. Okay, so then I made this. This is how our tables look when we put a report out. So this is kind of how I did it. So then I went, found my case, and I said, okay, what were my previous sperm fraction results? Well, on the left, the first column there, this is the type that I got when I did my proficiency test and I did my differential extraction. This was the type. And the next 2 columns were, I did 2 tubes of 50. I did do 2, cut them, amplified them. This is what I got. Every single peak was called in both tubes. And it was the same type. Again, I did edit those stutters, but I did that, blind. I had no idea And it did. It turned out to be correct. So, okay, keep the wheels turning here. Okay, here's case number 3. Again, it's a, crime kit swab or whatever from another proficiency test. And this is my result. Again, it looks like I've got a full profile here. You see some peak imbalance. That's a stutter, or at least what I call the stutter. And really at all the other loci, it doesn't, yeah, you do see some blips, but again, it looks like they're all stutter position. Does everyone agree? The percentage stutters. Oh, on this one, let me see if I can. Oops. Is it 21? I think it's 21%. Again, that's high, admittedly, but there are studies that have been done with reduced volume in our lab. I know, with different loci, you are going to have a little higher stutter than you would, let's say, with 28 cycles, and with studies done at 28 cycles of reduced volume, there are already increased stutter percentages. And this may be something I'm going to have to do too if I'm going to start doing some non-probatives or whatever, just to kind of see, what kind of stutter percentages am I getting. And again, here's a table that I did. Went back, found my old results. On the first column is the result from my proficiency test with my sperm fraction. And by the way, people, these were not just when the spots were made. It's not like they were just sperm. There were epithelial cells there. So I wasn't just cutting from all sperm or whatever. There were varying amounts of those proficiency tests. Sometimes they don't have a lot of epicells. So some of them, there weren't a lot, but they were there. But these are a little more of your ideal type of samples. But I wanted to show you at least that if I'm just taking a swab, doing this now, not something I've prepared, does it work? What's going to happen? And you can see again the other 2 columns. I made 2 cuttings of 50 sperm, and this is what I got. Same thing. I got the same profile, full profile. Looked great. And case number 4. And this one looked really pretty good. I didn't have any stutter on this one, or what I could see. And we do in our lab, it's kind of a little different. Like I know a lot of labs do a 50 RFU cutoff with 377. That we do also the same thing, but we also have a range of 150. We can do 150 RFU setting if we want, but if we see that there are minor peaks, like in a mixture or whatever, we always drop down to 50. Or if we're not sure about something, we always drop down to 50 just to see what else is there. But this looked really good. And again, I pulled out my old results and made a comparison, and sure enough, both tubes gave me a full profile at 50 sperm, 31 cycles, identifier, and it was the same as the previous results I'd gotten. So, these are a little more ideal samples, but this works. It makes me happy that this is working. And I didn't get any flatline samples, So, okay, now here's case number 1. I left this for the end. Case number 1 was actually a true sexual assault sample out of a kit that we had gotten that I guess they decided not to press charges. They said we could destroy the kit. So we actually get some of these kits like this, and then what we do is we use them for training of an analyst. And someone was training at the time, and she said, you know what, I had done this kit for training, and it had a positive swab. And I said, well, are there any left? And she said, yeah, there's 1 left. I said, okay, well, let me test it. I'll use this, because I knew that was one that was positive, and let me test it. Okay. All right, so this is what I get. Now, is this a mixture? Yeah, this looks, it looks like it. And this is at 50 RFU. So it's a mixture. I was like, oh, shoot. But I think, well, there's sort of maybe I think an apparent reason. Made the comparisons, okay. I put the epithelial fraction in here from her results just so, we would have an idea of what the epithelial, the victim's DNA type was. And she only did, when she was doing her testing, she only did one panel. So I've only got, we actually do SGM Plus and Profiler. We've got, these are SGM Plus results that she had. And I had done Identifiler, so I had a full, full panel here. But you can see I did two tubes cut 50 sperm, and both of them gave me a mixture. So it was pretty consistent. But the good thing was at least I wasn't picking, again, part of this is the increased cycle. I'm always worried, am I just somewhere down the line? Am I going to get an artifact I can't explain, whatever. But no, I mean, these were all consistent with the victim or the type of the sperm fraction. So at least if I'm getting these peaks, but they're still consistent with what I think I should be seeing if I'm going to get a mixture. But then I wanted to show you one more thing. This is what the slide looked like. It might be, is it kind of fuzzy? It is. But let me see. Is that the wrong thing to use? Let me see. Here's a bunch of sperm. Okay, and here's what looks like epithelial nuclei. I think this is one too. But as you also see, you see a lot of this stuff. I mean, I don't know. Does anyone know what this kind of thing is? I mean, we see this sometimes with our samples. I'm sure when you look at a spot of it, sometimes you just see a lot of debris or, I don't know. I don't know if these are cells breaking apart, epithelial cells breaking apart. So there could just be exogenous DNA, like Christine was saying, lying around. Maybe it's sticking to the sperm cells, whatever. I mean, this is what the whole slide looked like. So obviously, yes, there are some limitations to LMD. A slide like this, or a sample like this, I mean, I don't think there's going to be a way to get around picking up the female there. Maybe there, or maybe I can do some kind of cleanup. And one thing I also did see, like Christine, I still am having a harder time with epifractions. And I think, again, it's a cleanup issue. There's so much more going. And even though I try to just kind of circle the epithelial, the nucleus, rather than cutting the whole cell. But for some reason, I don't get the same results with epithelial nuclei. And I'm going to keep kind of working on that.
Did you work any cases where you saw a lot of lymphocytes or neutrophils in the smears?
I have not. These are the first 4 things that I've...
was, menstruating. So.
Yeah, no, I haven't. This is my first 4 true sort of cases that I've tried. Because like I said, I really have been spending a lot of time just optimizing and getting this right where I want it to be before I start doing the casework samples. So for this class, I specifically said, well, I want to try something here, and that's what I did. So I just quickly, whatever I could kind of find, I did. And I needed to do it in a short period of time. So, but I'm going to start trying to get a lot more non-probatives, and maybe even do a large casework study, like Christine suggested. I want to do quite a few. I think just we have to be able to put it into casework, just to show that it works. So, I think that's it for me. Oh, I can highlight that. And of course, Christine, she really started me right from the beginning. Okay, Kelly, try to do this. Because I didn't want to reinvent the wheel, She helped me a lot. And Pat, of course, he and I have brainstormed a lot. He's a PhD. He's got a lot of, good ideas. He's very creative. A lot of the DNA staff at the North Louisiana Crime Lab has helped me in some small way or another, whether it be cutting or whether it be like, the girl that had already done Identifiler, reduced volume, and magnesium studies. And of course, Andy's helped me a lot too, giving us slides. And so, but that's it. I hope I didn't go too long.
Were there any questions?
Questions? And we'll probably, are we having a discussion later?
I want to make a comment about the cleanup procedure, the pre-amplification lysis. We have another thermocycler. This is not the same thermocycler that we use for PCR amplification.
Yes.
I know y'all may be thinking, okay, you're doing this stuff in the thermocycler in the post-PCR room, but we're not. We have a separate thermocycler that's never had any PCR product in it.
Yeah, that is a good